Hi there, welcome to brilliantmath.com, where every student has an opportunity to excel in math. Today we are looking at Introduction to Linear Programming, Graphing Inequalities. But before we start, have you subscribed to brilliantmath.com? The resources are there for you. Subscribe and work. You have a lot of resources for independent practice. This lesson is taken from Brilliant Math Module 5. If you don't have a copy, grab one and let's work together. Graphical inequalities. Inequalities can be plotted on a graph. I decided to draw this so that this actually represents your graph sheet, so it will be easy for you to understand. The first inequality is x less than 9. It's a strict inequality. X is strictly less than 9. The line x is equal to 9 is here. We have our x and y axis. We have our grid. So we draw a line, a straight line, where x is equal to 9. But 9 is not part. So when the inequality is strict, you represent it by dotted lines. It's not a solid line. So I'm going to draw dotted lines at x equal to 9. Good. So that line is actually the line x is equal to 9. But the inequality that satisfies it, the region that satisfies x less than 9 is every space to the left of 9. As you can see, 9 is not part, so it's drawn in broken lines. So every space to the left of x equal to 9 satisfies the inequality x is less than 9. Let's look at the next one. Y is greater than or equal to minus 5. So we'll come to the y-axis. This is positive 5, but we're looking for minus 5, negative 5. So we come down, and that is negative 5. The line y is equal to negative 5 is a straight line parallel to the x-axis. But let's take note that here, y is greater than or equal to. So minus 5 is part of it, is included. The point is included, so we would have a solid line passing through y is equal to 5 and extending to both sides. So the region above minus 5, and minus 5 inclusive, satisfies the inequality. Let me extend the first line so we don't think it stops there. Okay. So that's more like it. If we were to shade the regions for x less than 9, we'll be shading every part of this. I'm just going to use light strokes since we are representing all of them on this graph. All right. This is a line y is equal to minus 5. Y equals negative 5. So if y is greater than or equal to minus 5, we have a solid line showing that negative 5 is inclusive, and then y is greater. So the region that satisfies that inequality is the region above y is equal to minus 5. We're just trying to graph these simple inequalities. The third one, minus 5 is less than or equal to x, less than 10. I take it again. Minus 5 is less than or equal to x, and x is less than 10. That means that x is greater than minus 5, but less than 10. So we have a bounded region on both sides. X is greater than or equal to minus 5. To disrupt our numbers a bit. So let's see. X is greater than or equal to minus 5. That's the line x equals minus 5. And it's going to be solid because x equal to minus 5 is part of the solution. All right? So that's a line x equal to minus 5. So minus 5 is less than or equal to x, or x is greater than or equal to minus 5. So it's to the right of minus 5. But x is strictly less than 10. X is less than 10. So we're here at x equal to 10. That is the line x is equal to 10. So this entire boundary, this entire region, from one black line to the other, satisfies the inequality minus 5 less than or equal to x less than 10. I hope you understand. Let me use a line to just show. Since you can see me do them, draw the lines. I hope it makes it clearer. Yes, and I'll write the 10 here too, so you can see. X equal to 10. So from x equal to minus 5 to x strictly less than 10 satisfies this inequality. So as you can see, the boundary from x equal to minus 5 to x equal to 10 satisfies the inequality minus 5 less than or equal to x less than 10, strictly less. And that's why the boundary or the lines are broken, because 10 is not part of the solution. The last one, y less than or equal to 4x plus 1 is a straight line. I'd like you to plot that line and draw it out in your graph book. All right, let's look at this example. Describe the unshaded region. We have the line y is equal to x. This is the line y equal to x because when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 4, and so on. So that's a straight line passing through the origin. And then the region under the line has been shaded, and we are told to describe the unshaded region, or find the inequality that satisfies the unshaded region. How do we find that? Choose points within the shaded region and check if it satisfies it or not. Let's see. This is y equal to x, and it's a solid line. That means that it's not a strict inequality. It will either be greater than or equal to or less than or equal to. So let's see. Let's choose the point x4, y1. Yes. That's a point within the shaded region. So when x is 4, y is 1. Can we say that y is greater than x? If y is 1 and x is 4, we know that y is less than x. So this region is a region where y is less than x. Let's choose another point. Say the point 2, 7. Or 7, 2 rather. When x is 7 and y is 2, we can see again that y is less than x in that region. So let's come to the unshaded region. We'll choose the point 1, 3, where x is 1 and y is 3. That's in the unshaded region. If y is 3 and x is 1, it satisfies y being greater than x. So the region above the line is a region where y is greater than or equal to x, and the region below the line is a region where y is less than or equal to x. So to determine the regions, you just choose points within any region on the graph, and then check if it satisfies the inequality or not. So in this case where we've been asked to describe it, we will now determine where it lies. 1, 3 is part of the unshaded region, and we can see that at that point, y is greater than or equal to x. So the solution is the unshaded region satisfies y greater than or equal to x. Remember that it's greater than or equal to because the line is a solid line and not a broken line. So it's not a strict inequality. That's very interesting. Let's see another one. Let's look at this example. Draw the graph of y plus x is equal to 6 and shade the region defined by y plus x is greater than 6. It's very easy to draw the graph of y plus x equals 6. Because when x is 0, y is 6. And when y is 0, x is 6. So we can easily plot those points on the graph. And we'll get our straight line. x0, y6. When x is 0, the point lies on the y-axis. And when y is 0, it lies on the x-axis. So that's our graph. Those are our points. And then we'll join the points together to get a straight line. You can extend your lines. Let's extend it a little bit. All right. So that's the line y is equal to sorry, that's the line y plus x equals 6. So I'll write it there, y plus x is equal to 6. See how easy it is to draw that line. The next thing we're supposed to do is to shade the region defined by y plus x is greater than 6. We need to know which of the regions, whether it's a region above the line or beneath the line. So let's choose a point. For example, the point 2, 2, where x is 2 and y is 2. X plus y, 2 plus 2, is that greater than 6? 2 plus 2 is less than 6. Let's try another point. So this is the region where x plus y is less than 6. So the region where x plus y is greater than 6 is the region above the line. However, x plus y is strictly greater than 6, so the line should not be a solid line. It should be broken lines. Because 6 is not part of the solution. So the line is a broken line. So the shaded region is the region defined by y plus x is greater than 6. Assuming we take the point 7, 8, where x is 7 and y is 8. 7 plus 8 is 15. X plus y is greater than 6. So that is the region that satisfies that inequality. Let's look at this interesting example. This is linear programming now, because we're going to use this to find the maximum profit a trader would make. A trader buys oranges at 15p each and grapefruits at 20p each. She must buy at least one of each kind of fruit, but her basket will not hold more than 5 fruits. These are the conditions that are being given, so please take note of them. If the trader makes a profit of 4p on each orange and 6p profit on each grapefruit, A, write 3 inequalities to represent the given conditions. B, draw graphs on the same axis to show these conditions. C, shade the required region. D, determine how many of each fruit the trader must buy to make maximum profit. And E, what is the greatest profit? You might be wondering, how are we going to use this to determine the greatest profit? But it's very easy. Let's look at the question again. What are the parameters or the conditions that we need to take into consideration? She must buy at least one of each kind of fruit. That is one condition. At least one. She could buy more, but it must be at least one. Also, her basket will not hold more than 5 fruits. That means that in her basket, she can't have more than 5 fruits. So that's another condition. Then before we then start talking about the profit. So let's take the solution. The first step is, let x be the number of oranges, all right? And then let y be the number of grapefruits, because we don't know how many of each the trader is going to buy to be able to make maximum profit. So let X be the number of oranges, and let Y be the number of grapefruits. The condition is this: she must buy at least one of each kind of fruit. So X must be greater than or equal to 1. And also, Y must be greater than or equal to 1. We're answering the first question now, where it says, write 3 inequalities to represent the given conditions. So the inequalities are X greater than or equal to 1, because it says at least. Y greater than or equal to 1. And then, but her basket will not hold more than 5 fruits. That's when you put the number of fruits together, both the grapefruit and the oranges, it shouldn't be more than 5. So X plus Y is less than or equal to 5. So these are the 3 inequalities that will satisfy the given conditions. So B says, draw graphs on the same axis to show these conditions. So let's draw the graphs here. We have our grid. The conditions are X greater than or equal to 1. So that's a line X is equal to 1, and then we'll find the required region. This is the line X equal to 1. So if it's greater than or equal to, it will be a solid line. It's a solid line, X greater than or equal to 1. I can label that X equal to 1. Then Y greater than or equal to 1. This is the line Y is equal to 1. So if X is greater than or equal to 1, that means that our required region is to the right of 1. To the right of 1. It's over here. Y is greater than or equal to 1. So here, Y is equal to 1. That's the line Y is equal to 1. So Y is greater than or equal to 1 takes, Y is greater than or equal to 1 is a region above 1, greater than or equal to. So this is our region. Okay, let's see. Then X plus Y is less than or equal to 5. So we'll draw the line X plus Y is equal to 5. So to draw that line, when X is 0, Y is 5. And when Y is 0, X is 5. So that's a straight line. X0, Y5, Y0, X5. All right. So X plus Y is less than or equal to 5. Is it on top of the line or below? So let's choose a point 4, 3. X plus Y, 4 plus 3 is 7. 7 is greater than 5. So this is the region where X plus Y is greater than 5. This is the line X plus Y is equal to 5. So that's the region where X plus Y is greater than 5. So that means this is the region where X plus Y is less than 5. So now, let's see the space that satisfies all three conditions. This is x equal to 1. This is y equal to 1. So the required region is where we're supposed to shade. So let me label the required region as a triangle A, B, and C. All right. So that's the required region that satisfies the conditions. B says draw graphs on the same axis to show these conditions. So we've drawn the three graphs, x greater than or equal to 1, y greater than or equal to 1, and x plus y less than or equal to 5. And this is the region that satisfies the three conditions. Let's go to C. C says shade the required region. We've shaded it. That is the required region, triangle ABC. Let me just put it there for you to see. Triangle ABC is the required region. D, determine how many of each fruit the trader must buy to make maximum profit. How many of each fruit the trader must buy to make maximum profit. So now, if the trader makes a profit of 4p on each orange and 6p profit on each grapefruit, so we have the profit will be given as 4x plus 6y. Since x is profit on oranges, and y will be profit on grapefruits. So 4x plus 6y, that will be the profit. So now we need to find the maximum profit. The maximum profit will occur at the vertices of the triangle. The vertices of the triangle, that's where you will get the maximum or minimum profits. So at those vertices, we take the coordinates. A is 1, 1. So that means x is 1 and y is 1. So 4x plus 6y will be equal to 10. So the profit at point A will be 10p. At point B, B is 1, 4. So that means x is 1. 4 times 1 is 4. Plus y is 4. 6 times 4 is 24. 24 plus 4 will be 28p. So at B, the profit will be 28p. At C, C is 4, 1. X is 4 and y is 1. 4 times 4 is 16, plus 6 times 1 is 6. 16 plus 6 is 22. So the profit at C is 22p. What is the greatest profit? From all these calculations, we can see that the greatest profit is at point B. And that is 28p. Stop the video, watch it over and over so you can understand. That brings me to the end of this lesson. Subscribe to brilliantmaths.com. You will be glad you did. There are lots of resources there for you to practice with. This lesson is taken from Brilliant Maths Module 5. Grab a copy and get more. Always remember, maths is fun, and you can do it.